Hello everyone, welcome to Learn Overflow. In this video, we will be discussing about selection sort. We'll discuss how this algorithm works, how we implement a selection sort in Python, and after that, we will just discuss about the time complexity and understand how the time complexity of selection sort is found out. So let's begin our video. So in computer science, selection sort is an in-place comparison sorting algorithm. So it sorts a place to place and compares the elements. So it is a bit inefficient for large list. If the array or the list we have is of large number of elements, say 10,000, 20,000, or a huge number of elements, then this selection sort is an inefficient one. It takes huge time in those cases, and its time complexity order of n squared, though we will discuss about the time complexity in the later part of this video. So selection sort generally performs worse than even the insertion sort. You remember the last video I uploaded on insertion sort, and I explained how insertion sort works, considering each element to be the correct place in their position, like correct position of an element. So if not, you haven't checked insertion sort, so the link is in the I button above. Just go and check how insertion sort works. But as of now, understand that selection sort is just is worse than insertion sort. All right, let's move on and understand how the selection sort algorithm works here. All right, so in selection sort, how we go about, we consider the first element, like when the sorting algorithm starts. So we consider the first element that we have here. We consider this to be our minimum value within the whole list. So arbitrarily we consider the first element to be the minimum value. So we consider this is the minimum value and all other elements in the array are greater than this. All right, so after that we make a search from rest of the elements, within the rest of the elements, and try to figure out that is there any one minimum than the value we considered here. So here, look carefully. Here we found a value that's minimum, or that's less than the value we considered to be the minimum. If we just search from this search within this area, then we figure out that there's someone that's less than the value here. All right, so in that case, how we go, we then swap these two elements. So we then just swap these two elements, and that's how we just consider that this position this position becomes our sorted array, right? This becomes a sorted array and this remains our unsorted array. Now next task is, we consider next in the second run, we consider this value to be the minimum one, and we consider this value to be minimum one, and we search for our value minimum, that like less than uh, 32 in the rest of the array. So here, if we just search for the rest of the array, so we again find 14 is there, which is less than 32. All right, so 14 is there, which is less than 32. And when you find that, so when you find a value which is less than 42, then our task is to swap that value. So we just swap these elements, and we just make this swap happen. And after that, after the end of the second round, we find that this area that we have here is our sorted array, right? And the rest of the area we have here is unsorted one. So what do you do? This area is our unsorted one. This remains our unsorted one after the second run. So after first run, this was unsorted. After the second run, this remains our unsorted one. All right. In the third run, what happens? In the third run, we consider the third element. The third element we have here as the unsorted, as the minimum value we have here, and we search for elements that are less than less than 23 in the rest of the array. Like we search for elements in this rest of this array, right? Look here, we just found that 19 is there, that is minimum, or that is less than 23. So once we find a value less than 23, we'll just swap it. In case we don't find a value that's less than 23 or less than the minimum value we considered here, then we don't swap it and we keep on moving through the loop. So once we found a value 19 less than 23, so we'll just swap this value. So there we just placed 19, we just swapped 19 and 23. After swap 19 and 23, the first three elements here becomes our sorted array, and the rest of the elements we have here becomes our unsorted array. Like this is the unsorted one. After that, we do a simple thing. We just, this process goes on like this. Then we again consider the first element in the rest of the array to be our the minimum value. So this becomes our minimum, like 32 becomes our minimum value, and we consider finding any other value other than 32, any other value less than 32 in the rest of the array. So we find no, there's 23 satisfying the condition that 23 is less than 32. So we just again swap 23 and 32, uh, making it like the first four elements to be our sorted one. So the first four elements became our sorted array, and after our fourth run, the first four will become sorted array, and the last two elements of our array becomes our unsorted one, right? So last two big elements remains our unsorted array. Moving on, we just repeat the steps again, and we find that uh, 41 and 32, like we consider 41 to be a minimum element, and we try to find out is there anyone less than 32 in the rest of the array. So yes, we find that happens here, and we again swap 41 and 32, and now look, we just found out the whole sorted array, like the whole array we are given got sorted, right? This got sorted, and that's how we just actually run a selection sort. So we just select an element to be the minimum and then sort it if we find a minimum value other than the selected element. So this is how the selection sort algorithm works. Let's understand the Python implementation, or let's see if we can implement this in Python, or we can figure out any good implementation out of this. All right, let's have a look at this function we have here. So this is a Python implementation of the selection sort. So what we are doing, we're considering an function. So we are considering a function with the name selection sort. So you can, as usual, you can name anything for the function, but naming it, keeping the naming convention same as the thing we're doing. So we just named it a selection sort and passed our array or the whole array within it. In this next case, we ran a loop for I, and how this loop runs, from here our if you just look for length of a for this array is 6, right? So length of a for this array is 6. So how this I can takes value, the I takes value from 0 till 5, right? I takes value from 0 till 5. These are the values that I would take in this range function. So here we just ran a function from 0 till 5. So the loop, for loop runs from this way, and we're considering the minimum to be I. Okay, the minimum to be, so minimum is a pointer here. If I, for the first case, if I, when a loop runs for the first case, so I becomes 0 in the first case, and we're considering our minimum to be I. So considering our minimum to be I means we're considering minimum to be the 0th element. What is the 0th element? Where the 0th element is 10 here, right? So the first case we just consider the 0th element. So that's what is the case we did first. We just consider the first element to the minimum, and then we again ran a loop of j for in I plus 1 till length of a. So what is I plus 1? I plus 1 is 1 till length of a. Length of a is 6, so it would run from 1 till 5. So this is the range that where our j would run in the first place. Remember, that was the steps we did. And after the first step, like inside our jth loop, for loop for j, we just find that we're just checking for a of min is greater than a of j. So what was A of mean? A of mean is A of 0. So this position we have here. And A of j in the first place is this position. So what's j going on? J going to this array elements. So the rest 5 array elements would j take. So we're just considering in case the first position element is greater than any of the elements, that is, we're just finding out the minimum value from within this any of the elements, then we are shifting mean to that value. In case we find a mean at this position, when initially when mean was 0 and we found out that a of j, suppose this position was greater than the minimum lies here, the value of a of mean is greater than the value of a of j, then we can make a changes to a mean and say and consider mean to be our jth value, right? That is the thing we did. We just took this value and then we just made a swap between this element, the element we found as the mean here, and the element that was at the beginning, right? So that was the swap we did. Look, a of I was at 0th position, so a of I and a of mean, so we just interchange the value to a of mean and a of I, right? This was the swap we did. So this was the steps we just undertook to understand how the selection sort algorithm works for us. All right, so I hope this way the selection sort algorithm works. In next steps, if you go on from considering I to be 1, consider I to be 2, if you just go on checking, then you can figure out that this is the one that goes here. So j would in the next step when I becomes 1, so j would take this number of values, so from 2 till 6, right? So these are the steps that it takes, and then if you will check if there is any minimum value within this elements which is less than this position when I is 1. All right, so we just consider, so in the first, after the first run, we just found that the first element we had here is the minimum here, and with that got fixed in that position. So I hope this algorithm working of this exact the Python implementation is understandable by you. If we just look at this Python implementation, if I just rub this extra lines a bit, then you will just find that there are basically two loops working in this function. So the first loop is this one, and the first loop is running for how many times? The if length of it's running from 0 till length of the array. If we consider the length of the array to be an element n, like any value n, then this loop runs for n number of times, like the total it runs for n different number of times. After that, we look here within this loop, for every run of this loop, like for each run of this loop, we find there's another loop running, which is again running for at least n minus 1 number of times. So why n minus 1 number of times? When I is 0, look, it's running for, if the length is 6, okay, if the length is 6, if I is 0, all right, and then j is running from 1 till 6, right? I is running from 0 till 6, and j is running from 1 till 6, so it's running for n minus 1 number of times. So for each run of the outer loop of I, there will be a run of inner loop of j. So this is basically n multiplied by, this way n multiplied by n minus 1. So if we multiply n into n minus 1, we'll see n square, mm, n square minus n. So the order of this function, if we just look for that, the order of this complexity, or order of this complexity is n square, since it's the most determining term here. So the order of the function, so the time complexity t of n is basically time complexity is order of n square, right? So that's how we figured out how the time complexity of selection sort is n square. Remember, when can this be anything else? In case our array is sorted, look for a boundary condition. If our array is already sorted, still we need to search for n square number of times, because we'll be searching here. If our we'll be again searching for the first place, considering it to minimum, and we'll again search for the rest of the elements to find if there is any minimum. So ultimately we won't find any minimum, but remember this loop would run, like this comparison statement would run for n minus 1 number of times, right? To figure out that whether there is any minimum element are there or not. So if this comparison statement is running for n minus number of n minus 1 number of times, then this n time the outer loop would run, and again n minus 1 number of times this inner loop would run. So that would make the selection sort algorithm run for still n square number of times. So if our array is sorted or if our array is reverse sorted, doesn't matter for us. In every case, our selection cell algorithm would give us a time complexity of order of n square, and why our this is the reason why our selection sort algorithm is less preferred than our insertion sort. Because if you remember in the insertion sort in my last video, so insertion sort, when our array is already sorted, that is the best case of insertion sort was order of n, since we can find out insertion sort in the best order of n case when the best case is there, right? So in case of larger array or a huge number of array elements, remember n become n square. If you consider maybe 1 million inputs in the array or 1 million array elements, thus consider it would be n square number of time, like the order would become n squared. So you can consider how big is that number going, right? So that was all for today's video. Thank you all for watching this video. I hope I could make you understand how this selection sort algorithm works. And if you have any doubts about selection sort, make sure you just put them in the comments below. I will just help you out if there is any. So thank you guys for watching this video. Hope to see you soon in our next video. Thank you.